Okay, geometry students, here's a video for example 5 and 6 for section 5.1. Finding equidistant points from the sides of an angle. An airport baggage inspector needs, well, I think I'm just going to hit play because you're going to be able to hear it from the question writer.
An airport has an automated system to direct bags toward the correct terminal. A baggage inspector is assigned to watch the point where the conveyor belt splits to make sure the system doesn't make any mistakes. To minimize the amount of time it takes to retrieve a misdirected bag, he needs to stand equidistant from the two conveyor belts. He knows that the distance between a point and a line is the length of the line segment from the point that is perpendicular to the line. The inspector finds that the first place he stood was too close to the conveyor on his left, so he moves closer to the one on his right. He notices that when he's standing about the same distance from either conveyor, the 2 points he's measuring to are about the same distance along each conveyor belt. So, to find another place to stand, the inspector picks 2 other points the same distance along the conveyors and finds the intersection of the lines perpendicular to the conveyor belts at those points. He notices that the points equidistant from the 2 belts appear to be collinear, and the line through them appears to bisect the angle formed by the conveyor belts. The baggage inspector marks the angle bisector with a line of tape on the floor, reasoning that as long as he stands over the tape, he will be equidistant from the 2 conveyor belts.
Yeah, this is it. So if you need to be equidistant on the sides of an angle, you can just do the angle bisector, and any point on the angle bisector is going to be the same distance away from the 2 lines. Okay, this is a little different than what we were doing before. Let's see what they have for a sample problem for us. Consider the 2 triangles that result from the drawings. No, we don't need to do that one. We're going to move on to example 6. Okay, here's the theorem. So to be equidistant from 2 sides of an angle, you can be any point on the angle bisector. That's essentially what this is saying. And you can have just the opposite. If you are equally distant from 2 sides of a angle perpendicularly, then AD must be an angle bisector. So they go hand in hand. Let's see if we can apply it here in example 6, hopefully. Okay, what's the value of KL? KL is this right here. We notice it's an angle bisector and the perpendicular segments, so we know 2x plus 3 equals 4x minus 11. So it's going to work on our algebra skills. First, we're going to write that equation, that 2x plus 3 equals 4x minus 11. And then they solved it. Okay, they didn't show their work too much, but they solved it. X is 7. Now that we know x is 7, we can plug 7 back in here. 7 times 2 is 14. 14 plus 3 is 17, so KL is 17. Let's try one on our own. And there's actually 2. One at a time, I guess. Click pause, give this a shot, come on back. Okay. I have it redone here. If HI is 7, so this is 7, and IJ is 7, okay, so they're both 7, so I know what that means. If they're both the same length and they're perpendicular, I know the angles are going to be the same, right? The measure of HGI is 25. HGI, so this one right in here is 25. What's the measure of IGJ? IGJ. Well, if this one's 25, because of the setup, I know this one's also 25. So 25 is the answer to that. All right, what's the next question? If the measure of angle, I think this is a different problem, so let me go to a clean screen. Give this a shot. Click pause, come on back. HGJ. HGJ. So this whole thing is 50. If the whole thing is 57, oh boy. And the measure of IGJ is 28.5. Oh boy, 28.5. The whole thing is 57, and this part is 28. Well, let's see. 57 divided by 2. I think might be 28.5. 57 divided by 2. Yes, 28.5. So that means this is an angle bisector. All right, this is that special setup that we need to have. And HI is 12.12, 12.2. What is the value of IJ? Okay, so this is the angle bisector. They're both 28. We have perpendicular segments. That means these two segments, HI and IJ, are the same. So if HI is 12.5, so is IJ. That's the answer. From those two examples, you should be able to do 18, 19, 25. I don't know why I put a question mark there. 11, 12, 9, 10, 21, and 27. That's it for this video. Have a great day.